Hi everyone, welcome. I'm Dario. This talk is titled Hot Reloading in React, What They Did Not Tell You. The purpose of this talk is to give you an idea of how it works, hot reloading in React, when it works, and more importantly, when it doesn't work. In my experience, sometimes it can be quite frustrating or confusing to see errors pop up when you implement hot reloading in React. And I just want to give you a little bit of an insight on possible issues and how to avoid those issues. So let me start with introducing myself. I'm a full stack engineer at Super. That's mostly on paper though. I mostly do front-end stuff. I've been doing front-end stuff for roughly 10 years now. I have a lot of opinions. I'll give them for free. Super pays me to give them. And I'm here because Robert asked me to do this talk. Robert is also my manager. So thanks for the invitation, Robert. So this talk, it's about hot reloading, which is a magical, amazing concept in theory. However, it turns out that it's maybe a little less amazing in practice. Again, it can sometimes be quite a confusing thing. I often see people use it, and then a couple months in, they decide it's not worth the effort, it's actually slowing me down. So before we start, I would like to get a little bit an idea how you all feel about hot reloading. So the first one is, who of you have never bothered to set it up, or never had the time, or anything like that? Can I see some hands? Okay, so most of you have worked with it. How about the people that use it but refresh anyway all of the time? Yeah, figured as much. How about the people who've actually turned it off because it started to annoy them? Still, okay. And how about the people who are infallible magicians and have it working all of the time? No one, right? Oh, we have a liar. Okay, we have a liar. All right. So first maybe explain what hot reloading is. So this tweet is it's a pretty historical tweet. It's by Dan Abramov, the original creator of React Hot Loader. It's over 3 years old now. It basically says, check this out, I'm live editing a React app without refreshing. So that's it. Now seriously though, the idea of hot reloading is the ability to replace code in a system without actually shutting the system down or restarting it. And in the context of a web app, which is what we're talking about today, it means the ability to re-render your application without actually having to do that full page refresh. And what it means in the context of a React application is that you will have the ability to re-render the application without losing local state. Why do we want reloading? Well, the main thing is faster feedback. You can go from a normal development process where you have feedback from anywhere between 3 to 4 seconds, maybe even more, to getting feedback in like half a second. That keeps you focused. For me personally, if things take longer than 3 to 4 seconds, I lose focus. Like I look at my phone, I look at a different tab, and things that should take me like a couple seconds will end up taking me a minute. So it definitely helps to see the changes almost immediately on your screen. And another thing is that we're able to maintain state. If you have something that you're testing on that requires you to do an amount of user interactions, for instance, you're testing a form or you're styling a form or whatever, it can be quite cumbersome to have to deal with the fact that for every change you make, the browser will have to do a full page refresh, and you will have to repeat those actions. It can slow you down, and that's not what we want. So what we want is productivity. As far as the building blocks for getting hot reloading to work in React, one of the things is Webpack, which is a code bundler that probably most of us use and definitely most of us complain about. Then we have Babel, which is a JavaScript compiler. It's mostly used for compiling newer features of JavaScript into a subset of JavaScript that is supported by older browsers. And we also have React Hot Reloader, which is the library itself, of course. As far as Webpack, well, just a basic introduction. Webpack bundles your code. That means it collects all your JavaScript files and emits one file that you can ship to your users. It also has a watch mode, where files are being watched for changes, and on every change it will emit a new version of your bundle. And it also has something that they call the hot module replacement mode. Now, I wanted to do a really thorough explanation of what hot module reloading exactly is, but it's actually quite a simple graph on the old Webpack website that explains precisely what it does, and that's this. Now, I don't know about you, but I could look at this for 2 years and I still would not understand what this means. But I did the work, so I'm gonna try to explain it a bit. So the way that it works is when you enable hot module replacement for Webpack, it includes a small piece of code that when your browser executes it will open a WebSocket connection to the Webpack process. When Webpack sees a change coming in, it will actually send just the changed modules to the browser, and the updates will be received by the browser. They bubble up in the sense that if you have module A that imports module B, if you don't accept it in module B, it will bubble up to module A. And if no one accepts the update, the browser will do a full page refresh. And this is basically how it looks. Check for the existence of the hot module replacement API in the module object. Tell Webpack to accept updates for the app folder, and then in this case, we refresh the browser, which is obviously something that we want to avoid, but just to give you an idea of the concept of accepting hot updates. Then we have Babel, which is, again, mostly used for compiling newer JavaScript into older JavaScript, so to speak. It's actually much more than that, though. It has a plugin architecture that allows you to do basically everything you want with any JavaScript file. It will allow you to edit, to make changes, to add code, to remove code, etc. It's like super extendable. So just to give you an idea of what's possible with Babel, there's this plugin. I'm just going to read it out loud. It's Babel plugin transform React pure class to function. If you're not familiar with the Babel plugin ecosystem, it seems like it's sort of a sport to come up with the longest names, and this is definitely a contender. But the idea of this plugin is to traverse your module, try to see if it can find a class component that only has a render function, and then it will change that class to a functional component. I'm not sure what the exact idea behind it. Could be something like file size, could be something like performance. But just to give you an idea of what's possible beyond just compiling new to old. And as for React Hot Loader, the library itself, that was originally written by Dan Abramov a couple years ago. And I think, some other people took it over now, and they just released the third version. Version 2 and version 1 were even worse. The slogan is tweak components in real time, and I think it's very significant that they say tweak. Like, they don't say change, they don't say do a big refactor. If the scope of your change is like small, you'll be fine. But anything else than that, you'll have some issues. So what the library does is it will help us re-render the UI after an update, and it will make sure that the latest version of your component is actually rendered. It also helps us keep local state. It comes with a Babel plugin, which I will explain in a minute. It comes with a small runtime that you have to include in your code. There's also a use case without Babel, with just Webpack, but that's so limited, it's not even worth discussing. So this is how it looks. This is how a basic React hot loader setup looks. So obviously we have the basic React tools to render the application, and then we import the app container. And we create a render function to render the actual application. And as you can see on line 7, we actually require the module over there. And that's pretty important, and I'll get back to that in a minute. And the last thing that we need to do is, we need to accept the hot update for the app component, and then re-render the application when an update comes in. And another part of React Hot Loader is the Babel plugin that they provide. The goal of the Babel plugin from React Hot Loader is to basically find every component that it can find inside of your code base. So the way that it does it is it traverses your modules, it finds all the top level variables. So for instance, here we declare the foo and the bar component. and React hot loader will add a small piece of code that registers those components uh, with their ID and their file name with the runtime. And the next step is, probably the most complex part, is the hot loader runtime. So you have to include a small piece of code inside of your application. It has a component registry. Again, it has those components matched by file name and ID. Whenever a module is executed, the components will register with the runtime. At that point, the hot loader runtime will create a proxy version of that component. So it's not actually the component, but it's something that proxies to the component. And this proxy, it can update a component type without unmounting the component. What normally would happen inside of a React application, the way that React works is when it sees two different types and it checks that by identity, it will unmount the component. But the proxy component makes sure that the identity is preserved of the earlier version, and you will be able to update the class of a component without causing an unmount, which helps us maintain local state. And last thing that it does is it overrides create element, which is a React function. If you don't know what that is, it's basically something that you call every time that you write JSX. There's actually just a react.create element call, and it will return the proxy for a type if it has that type in its registry. And as far as handling the update, so first off, Webpack will send that update to the browser. The app will accept that update. It will re-require the module to make sure that the module is executed and the component is re-registered. And when the component is re-registered, the proxy component will be updated with the new version. And when the next time when the application is rendered, which is something that app container takes care of, we will render the new version of the component. And then it works. It's magic. You feel amazing, you feel productive, you feel the best developer in the world, but all of a sudden you notice that something is wrong, like some things are missing, like I didn't expect this. And you open up the console and you see all kinds of red errors. I'll just refresh just to be sure. So what does not work about in React hot reloading? The first thing that doesn't work is async arrow functions. An async arrow function is a class property, just like any other arrow function. And the Babel plugin does some weird stuff with class properties. That has something to do with the way that React proxy works. But in any case, the end result is that it's not reloadable. It's ignored. If you update an async arrow function, you won't see that change in your browser if you refresh the page. And you can sort of see it over here. We have a foo function that is an arrow function. It references a class method, and then you have an async arrow function that is actually left alone. So React will never see the update. Another thing that doesn't work, so apologies, is code splitting. So for those of you who are not aware of what code splitting is basically a way to split up your JavaScript file into smaller files. Like especially if you work on a larger application, you can easily ship like a JavaScript file that's larger than 1 megabyte. At that point, you'll have to use code splitting to split it up in smaller files. And Webpack will load those files for you on demand. The problem though with code splitting is that the updates will only bubble up to the split point. So if I define a split point in module B for module C, and I import module B and module A, I hope you can still keep track, but the update never gets to module A, and we don't know how to re-render. And just to give you an example, this is how code splitting looks in the context of a React application. We're using a helper library here, which is React loadable, to create a lazily loaded component. And the important part is on line 5, where we have the dynamic import statement that imports the module on demand. There are ways around this. There are ways to deal with it. What I see people doing quite often is to add synchronous require statements in development mode for the modules that they have code split. That makes it work. Like that tricks Webpack into thinking that it's one big chunk, and the update will bubble up correctly, and you will know how to re-render. And the other thing is that we did at Suva is we wrote a Babel plugin that actually adds a regular import every time that it sees a dynamic import, again in development mode. Sorry, I deleted the code. Anyway, let me get back. Anyway, yeah, so that basically just replaces dynamic imports with an immediately resolved promise that is the result of the static import. Another thing that is really hard to get right, and it makes sense that it's hard to get right, is lifecycle methods. So you have lifecycle methods like component will mount, component did mount, the constructor. They are obviously not called if a component stays mounted. So if you change anything within a render method that depends on changes in the constructor or component will mount or component did mount, like that could break your render method because the lifecycle methods are never called. And the only way out here is to refresh, like there's no way around it. If you want to keep local state, you won't have the updates in your lifecycle methods. Another thing that breaks quite easily is functional composition. Functional composition, or also known as higher order components, is basically a function that returns a component that renders another component. It's a pattern that's commonly used in Redux, React Router, Relay. Like the prime example is the connect function from React Redux. The problem is with it though is that it hides components from React Hot Loader. React Hot Loader can only see the top level variables in your module. And if you have multiple layers of composition, then React Hot Loader can no longer see certain components, and it will cause issues. So here we have an example. So we have the foo component, and then we have the connected component with 2 layers of composition, which is the connect function and the with router decorator, which you might know from React Router. So what happens in the output is that you can see that there are only 2 components being registered with React Hot Loader, because it's not able to tell that the argument that you pass to the connect function is a component as well. And the effect that that will have is that the component will be unmounted and remounted when you re-render the application, because the hot loader runtime does not have a reference to this component. The way you can work around this is you can, of course, you can declare a top-level variable for every phase in your composition. Yeah, that requires you to update your modules to actually make that work, of course. There's also a plugin I found out a couple days ago. It's called extract-hoc. It basically does the same thing we just described, but then automatically. And this is how it looks. If we go back to the previous example where we declared 1 component and 2 layers of composition, you'll see that it actually declares 2 different exports for both phases of that composition. And this definitely helps with making sure that functional components maintain state as well. And some other tips. The first thing is make sure that the errors that you get are visible. So when the application re-renders, catch that error and do something with it. Like it doesn't really matter what. Either refresh it, or you can add a component like redbox, which overlays a big red layover with the stack trace. But at least make it visible to keep you aware of the fact that something has gone wrong. But another thing is functional components are your best option. Like if you change a functional component, like there are no edge cases, it will just almost always work. Also, hot reloading is great for style guides. Like at Silver, we use style guides, but I think you can use things like Storybook as well. Just a focused environment where you only have logicless components, like just dumb components. In that context, it works great. If you want to add state and logic, you just do it in the context of your application. But at least you can do the styling changes within the context of your style environment. And last thing is avoid hot reloading as a whole. For some people, it might not make sense to use hot reloading. If you don't have server-side rendering, if you have a fast rebuild, if you have a fast reload, you might just want to avoid it, because if you can get consistent feedback within 1 second, you'll still be fine, and you might not need it. And I think that's it. Do we have time for questions?